This video is brought to you by StarCharge, the largest EV charging manufacturer in the world. They are also a provider of residential and commercial battery storage with microgrid solutions.
Sending it, nice. Full ABS, into the turn, hit the apex. Good morning and welcome to another Out of Spec Reviews video, and welcome to the port of Long Beach. I'm here with Toyota showing their new fuel cell energy situation down here, the TriGen setup, where they generate hydrogen and usable water, probably not drinkable water, but usable water, hydrogen and electricity, and they're starting to power most of the port with renewable resources. They're really trying to jump into that game. Now, Toyota has a pretty multifaceted approach to their renewable energy mindset. They're not full send on EVs like some other companies. In fact, famously so. Their EV actually isn't the best. The BZ4X is fine, but if you want to go on a road trip, do a lot of DC fast charging, set records, you're not doing any of that with that. But I do actually like it as a car. Now, they also are really jumping into hybrids. In fact, they were kind of spearheading the hybrid game. A lot of people thought with Toyota that maybe they would lead the charge with EVs because they led the charge with hybrids, but not so much the case. In fact, Akio Todo was himself saying, this is not the future. EVs is not the sole piece of the immediate future, which maybe he's right. So I've been out here with Toyota for about a day and a half, checking out their hydrogen approach, the fuel cell situations. Of course, I do have hydrogen combustion engines as well, and then hydrogen fuel cell, which we're going to be looking at mostly today. Hybrid internal combustion engines, even mild hybrids, plug-in hybrids, EVs. They've gone this whole multifaceted approach. So this should be really, really interesting. But anyways, we're out here with the trains. It's really cool to watch trains all day. I could literally just train spot all day. We're actually going to see some messages from the mayor and probably executives at Toyota, just basically talking about this station. I don't really know what to expect, honestly, but let's actually jump to yesterday when I got to see a sneak preview of the Toyota Technical Center, TTC, where a lot of their hydrogen development actually happens. For a long time, it was sealed in secrecy, and now they're finally opening it up, their new hydrogen headquarters, to the public. So, to yesterday. So the first part of this video is actually over here in Gardena, California at the Toyota Technical Center. This is a whole new thing where they are inviting journalists to see what was originally a completely locked down video. Now it is their hydrogen capital for their development, at least here in the US, as far as I know. But yeah, there's a hydrogen truck behind me, a lot of interesting things in that building, and we're gonna be taking basically a full tour of the whole premises. But this is pretty cool just on the outside here. This whole thing was remodeled. I think it's been around for a while. There actually used to be a lot of offices over here, and now it's hydrogen development stuff. And we'll see so many things. A 1.2 megawatt dyno, hydrogen fueling cells just laying around everywhere, a filling station, all sorts of things to jump into. So let's go take a look inside. Walking in, this is the basically toy shop, the play shop, where everything is really tested and developed and tested again. We'll get over there in a second. That's a 1.2 megawatt dyno. But there's a lot to get into in here. First thing we're greeted with is actually a Gen 1 and Gen 2 Mirai. Side by side, same color. Pretty cool to see the changes over the years. I'm guessing this is a late Gen 1 because the earlier ones were, I don't know, a little bit ugly. I don't know when the facelift was, but pretty cool to see them side by side. And actually, you can see how the interior has also changed, just in case you're curious. Looks, comparable, but the second Gen 1, definitely a step up. That is straight up Lexus LS vibes on a Toyota product. And over here next to the Mirais, we have some actual componentry, including kind of an opened cell. And I have Daniel here, who's a bit more subject matter on it than I am. So Daniel, what are we looking at here?
So here we've got our two different packaging options for the fuel cell module. We've got the Type 1, which you can see is shaped like a cube, and then we've got the Type 2, which is shaped more like a rectangle. What we've done is taken the entire powertrain out of the Mirai and basically put it in a box. So all you need to do as the customer is provide a high voltage connection, hydrogen, cooling, and a control signal, And the fuel cell is basically ready to go as a black box that will generate power for your electrical system.
Nice. Are these like Mirai Gen 1 or Gen 2?
These are Gen 2 systems.
Awesome. Okay.
Yeah.
And so it's like a plug and play box, more or less. People can do whatever they need to with them. What are some examples of like what people would do with them?
So we've done a variety of applications. You know, you could make a light duty vehicle with it if you wanted to. We've made heavy duty vehicles with them. We've made stationary generator demonstration projects with them. We've made various pieces of equipment at the port. You know, you could do aviation if you wanted to. There's pretty much whatever application you need a box to generate DC electrical power for.
Super cool.
Yeah.
And then what is this over here? This is like almost like an exploded view.
Yeah. So over here we've got exactly an exploded view of our fuel cell stack. This box down here is the actual stack. You can see all the cells lined up in there. So the Gen 2 system has 330 cells. And again, they're making, DC power. The top portion there is what we call the FCPC, fuel cell power converter. And that actually folds down and sits on top of the stack. These are the two end terminals of the fuel cell stack. So these two connect into bus bars here. And the purpose of that is to actually boost the voltage up to 650 volts, which is the kind of nominal DC bus voltage that we tell customers to interface at. And we've also got inverters in there for some of the balance of plant components like the hydrogen recirculation pump and the water cooling pump.
Nice. So yeah, and really high level, I mean, how does this work? I guess I could see all these different like labels for like how things are done. I'm sure you could go into it forever, but really high level.
So basically you put air in and you put hydrogen in the other side, and they flow through a manifold, and then they actually flow across the face of every single cell. And in the anode, you have the hydrogen separating into a proton and electron. The proton permeates across the membrane, the electron runs through the circuitry. It meets up in the cathode with the oxygen, forms water. The water comes out of the exhaust right here. And it's basically a voltage source, just like a battery, except instead of the energy being stored in here, the energy is stored in the hydrogen, and it's converted in here into electricity.
Super cool. And then you have different wiring for monitoring all the different modules. I mean, there's like 300 and something, 330?
Exactly, yeah. We've got 330 cells, and this is the cell voltage monitor. So we're actually able to monitor the voltage of the end cells, which are the most prone to flooding.
Okay.
So we're using that as kind of an active control mechanism to make sure that everything in the stack is being maintained well. And then we're actually, within the body, we're monitoring the voltage of every other cell. So we can, again, make sure that all the conditions are being maintained properly.
Gotcha.
And that's really the key with running the fuel cell system, is you have to make sure that the stack is being well taken care of.
Yeah, and so there's kind of an ECU type thing monitoring everything.
Exactly.
And then I guess in those situations over there, if a customer is using that, I mean, how much data do they have access to, and is it up to them to do what they will with that data?
They have access to what I would say is a limited subset of data that is enough for them to use this as a black box as part of their system.
Gotcha.
This is basically standalone, and the fuel cell has its own controls. It will have its own diagnostic codes. It will protect itself. It will operate itself. The customer doesn't need to worry about how much they need to run the cooling pump, or how much airflow they need to provide, or hydrogen pressure, or humidity, or anything like that. It's all taken care of inside the box. All they need to do is tell it how much power they want to make, and that's what they get.
Nice, very cool. In the middle of this floor is this huge yard truck, or yard dog as they like to abbreviate it, or nickname it, I should say. But basically a single seat, single partial cab situation, and yes, Toyota fuel cell. I can't remember if this is Mirai Gen 1 or Gen 2 stack in there, but it's just a single one. This thing doesn't need that much, power. If the gearing's right, if everything's done right, and it's also slow moving. It's just kind of a port truck. So it works at the port in like LA, and also internal to Toyota's own huge warehouses or wherever that is. But pretty cool to see all the different varieties, and I guess the actual engineers who drive this thing, who are licensed, they like how quiet it is compared to some of the diesel alternatives. So pretty cool to see this in the middle here. Not much to share beyond normal tanks and stack from a Mirai Gen 1. This thing is paired with a Toshiba battery along with that first gen Mirai system. So it gets about, I guess, 8 to 12 hours of work time before it needs to be refueled. And then, you know, refueling doesn't take as long as it would with a huge lithium ion battery and via DC fast charging. You know, I guess there are ways to do really fast DC fast charging with larger commercial components, but in their case, in their testing, they're trying to use the hydrogen situation. What do you guys think? Does it make more sense to use hydrogen or electric in this case? I'm looking for the answers to these questions myself, but it's curious to see Toyota's version of, you know what, hydrogen maybe works better. Here's the tanks over here on the side. All right, over here we have Cliff next to this Toyota Tundra. No, this is not hydrogen powered, but it's pretty cool to see the new Tundra put to work. In this case, carrying some, I guess, testing equipment. What do you guys do with this?
So we call this our hydrogen dispenser test apparatus, and what we use this for is going out and commissioning new stations, making sure that they're going to perform well for the customer. So what we have here is a Tundra basically with an entire hydrogen system of a Mirai in the back of the bed. So we can fill these tanks just like you would a vehicle, and at the same time we're also collecting data to ensure the station's functioning properly. Cool. The nice thing about this is that other than a vehicle you have to drive to defuel it, we can run series of tests back to back by purging this tank system without having to drive it.
Yeah, so you could fill it just like a car and then purge it and then fill it again, just to like double verify?
Yes,
nice.
Exactly.
And then I guess an example you guys mentioned earlier is like, also by this being a normal truck, not a fuel cell truck, it's like if a station has a serious issue, you're not relying on that to get you home.
Exactly, exactly. Yeah, if there's like contamination or impurity, something like that could happen. But yeah,
super cool.
It's a useful tool for us. It's makes testing stations much easier and quicker.
So you can test stations. Do you use it to like commission things, commission stations?
New stations that come online that are just newly built, we'll use this to make sure that they're following the SAE protocol when it comes to fueling.
Nice, very cool, thanks. Okay, over here we have Amy with a few tanks, including some open tanks, so you can actually see what they look like on the inside. I guess, yeah, how are these basically constructed?
So what you see here is a cutaway of a Mirai tank. So this is the plastic liner. These are what we call type 4 tanks. So what that means is they are plastic on the inside, and that keeps the gas inside and not leak. And so what happens is this is actually injection molded into a carbon fiber overwrap. And so this is the carbon fiber, and that provides the strength to the tank. And then on the very outside, we can see this. Oh, this is a better example here. Is the glass fiber or glass overwrap layer. So that's kind of a shiny smooth layer. And so you don't want, it's just for protective purposes. It's not load bearing. And then on the side, we have some tank dome protectors from drop, and they also help with fire resistance. And on each of the tanks, we have valves, and that can probably be seen better over on these displays here. And this is the valve for the tank. So it includes this is what we call the on-tank valve. And so when the hydrogen is fueled from the station through the receptacle, it goes through these tanks or into these tanks. And we have 3 tanks in the Gen 2 Mirai. So starting with the big one, this goes along through the center column of the Mirai second generation Mirai vehicle. The number 2 tank and the number 3 tank, they're all similar designs, type 4, with the valve and the end bosses. And these tanks have been tested rigorously to withstand a 20-year service life. And they're tested in all the ways that you can think of. We drop them, scratch them, put them fire, gunfire. Everything.
So they are like guaranteed for 20 years, but sounds like they might last longer.
A lot longer. That's what I'm thinking.
Nice. I guess what is like the safety questions that come up? Like people are wondering like, oh, like pressurized, they get scared of that whole term. But I mean, assuming it seems like, carbon fiber is a super strong material. So that's like the actual structure of the tank. And like you said, the plastic is what contains the hydrogen.
Correct.
And then this is like protecting the protective part, like Or I guess the
some
structural part.
scratches. Yeah.
Yeah.
The glass fiber actually doesn't hold any. It's not weight bearing or
Yeah.
pressure bearing. But these tanks are tested to withstand multiple fuelings, because that's what that's cycling.
Yeah.
It puts stresses on the inside of the tank. So we put it through many cycles of complete fueling and defueling with hydrogen gas, different temperatures of hydrogen gas, different external temperatures. We test really cold, so that's like minus 40 C,
Wow.
which is minus 40 F, I guess, at that point.
Yeah.
And 85 C, so that's 120 something degrees. So we tested in all the most rigorous or extreme temperatures that you can think of.
Okay.
There's also safety. These tanks work in conjunction with the other safety features in the vehicle, that like the hydrogen sensors that are in the vehicle that detect any type of leakage and will basically, shut off the hydrogen supply, the valves to the tank, and alert the driver. So
Nice.
there's multiple ways that we prevent or keep drivers and passengers safe in a hydrogen vehicle.
Okay. And these are kind of the smaller, like, consumer vehicle tanks. And then these over
That's
here, are these
right.
like the bigger commercial ones?
Yeah, so basically they look the same if you just look at it.
Yeah, just
they
blown
are so they're the same design, and they're qualified to the same stringent standards that our
Okay.
light duty vehicles are,
Yeah.
and they are just bigger tanks. So we're using them in the large trucks that you can see behind us.
Yeah.
But they have the same safety features, the same all the safety features that you would expect.
Okay. And it's really kind of a scalable design. I mean, you could build, like, in theory, super big ones for crazy
Absolutely.
big
Yeah, have you seen
purposes. Yeah. So what would that be used for? Is that just another?
that guy? Yeah, that's just going to demonstrating another. That can go in a truck. It can go in any kind of mobile application at this point.
And a sweet little forklift from Japan, I guess.
Yeah, so that's a hydrogen fuel cell powered forklift.
Awesome.
This was used in our one of our plants in Japan to move things around. So
Super
the
cool.
applications are
Endless. sort
very
of. Awesome.
gone beyond the Mirai here.
All right, outside of the main floor area, we have this kind of garage playground in here, and Andrew, who's a principal engineer over here with Toyota, and a Mirai up on a lift with some underplating removed. So what happens in this garage space?
Yeah, so this is our hydrogen garage. It was specially built for us to test and to develop new hydrogen products, and even some prototypes that maybe won't even make it to production, but we can, like you said, it's a playground. We can test different things.
Nice.
The garage itself was built with all the ventilation, all the safety, all the sensors for hydrogen detection, hydrogen leaks. We really play. So for safety, this is the best place to do all of our hydrogen work and development. On the lift, we have a second-gen Toyota Mirai with our teammate level 2 autonomous technology. So that's why you'll see some of the LiDAR and radar sensors around this vehicle. And we did take the plates off of the bottom, so you can very easily see our hydrogen storage in these 3 tanks. You can see the electric motor, the battery, and the fuel cell. A little bit more difficult to see, but this is not a view that we usually get to show people. But you can see all of these hydrogen lines, some of the high voltage cables, and it is a electrified vehicle with an electric motor, and like a conventional vehicle, you can fill it up in about 5 minutes. It fills up with hydrogen gas, 5.6 kilograms in these tanks, and then it has an air intake. And where the engine would be, we have the fuel cell system. So with that chemical reaction between the air and the hydrogen, we're generating electricity, which can be stored in the battery or used at the motor.
Yep. That's very cool to see. And yeah, not a view we usually get. And I guess this is where the exhaust is, which is actually just water vapor? Or
Yeah, so you have hydrogen, you have oxygen, and when they come together, they make H2O, and that's all you get out of the tailpipe.
Nice. Very cool.
So we have a couple lifts in this garage. This one, we have one over there and one over there. So we do work on vehicles, some prototype vehicles, and the Mirais as well, of course. But we also work on the fuel cell stacks themselves and some stationary projects. So you may have seen outside we have a fuel cell generator, which can power, you know, a stage, or even be backup power to a building, or be part of a microgrid, such as at the NREL laboratory in Colorado, which is what's being shown on the TV screens over there.
Awesome, yeah. So I live 5 minutes from that facility on the screen right there.
Okay, great, yeah. So
In
they've
Colorado.
integrated our Megawatt fuel cell generator on their microgrid over
cool.
there. And most of that was tested and developed here. We had 4 fuel cells running at the same time over here. It's the first time that we've done that. You've seen on some of the heavy duty trucks, we have 2 fuel cells running the heavy duty trucks, but over here we're using 4 fuel cells all at once. And then now we call them a quad, and we can use those quads and stack them up to like the Megawatt system that we have over in Colorado. But we also worked on the generator that was outside. We worked on the TRD generator as well, and a lot of that work was done here. Being our playground, we have various parts. We have our electrical bench. We 3D print things. We mill things. We make all kinds of parts that we might need during our testing and prototyping.
Nice. And I saw this big electrical line coming from the wall over here. Like, what was that used for exactly?
Well, when you're running 4 fuel cells all at once, you generate a lot of power, and you need to dump that power somewhere. So we have things like a battery emulator, so we can emulate a large capacity battery, and sometimes we have to dump power, so that's a very big
Nice.
power plug that you see. And you'll see some other similarly big wires at our dyno that's over there, the 1.2 megawatt dyno, where we also test a bunch of components, even the full heavy duty vehicles
Very cool.
systems.
And I guess for the tanks in the Mirai, are those like, I know it's like 5.6 kilograms. Is that like, are the tanks running sort of a parallel or like a series situation?
That's a good question. In those terms, I would say parallel.
Yeah.
They basically act as one tank, and what
Okay.
you'll see here is the manifold. So you'll see all 3 inlets going to one manifold, all 3 outlets going to one manifold. So when you fill up, it's filling up all 3 of them at once.
Yeah.
And when you're using it, it's depleting all 3 at once.
Okay.
So we're not individually managing them.
Yeah. And so the idea of having 3 tanks is really just to allow you to spread out the hydrogen throughout the car instead of having one bigger tank that's like hard to package?
Yeah, it's really a packaging thing. So we put them where they fit.
Okay.
You could, using these manifolds, we could add more tanks.
Yeah.
But you just have to find the space for them.
Gotcha.
Or you could use one big one, or you could use 6 very large ones.
Like in the trucks, yeah.
Yeah.
Super cool. Yeah, this looks like a fun playground. I'm a little jealous. My garage at home is nowhere this size.
Yeah, neither is mine, but at least I get to come here.
That's awesome.
My name is Scott Friedman. I'm a senior program manager here at Toyota, responsible for the Project Portal, our heavy-duty truck
Awesome.
powertrain system.
Project Portal. So we just missed the truck. I mean, I got some clips of it driving out, but that's I guess specifically a partnership with them for that one. But this is basically like a rolling buck that you can sell to whoever, I guess?
So we're developing a powertrain kit that we can sell to any truck OEM that wants to electrify their fleet. So it's a kind of a plug-and-play option that we give to virtually any Class 8 tractor company that wants to take their diesel setup and turn it into a fuel cell electric powertrain. So
super cool.
We're able to package in similar locations. For example, we have our dual fuel cell stack module here that it's built in Kentucky, assembled in Kentucky with various components. We have air cleaner boxes, we have a single point interface for cooling, we have a single point interface for hydrogen, we have a single point interface with our electronics as well, high voltage and so on. That's paired with our high voltage battery pack. So essentially, if you think about a 2 fuel cell stacks.
Yep.
With two strings instead of a battery pack, so in parallel, matched with some hydrogen going to electric drivetrain.
So how many kilograms of hydrogen are we talking on this?
So these are 6 10-kilogram tanks.
Okay.
So 60 kilograms.
Yeah.
Roughly gives us a range of between 350 450 miles at 82,000 pound combined weight. So it could definitely haul, and we kind of put it through its paces.
Nice. And then what size batteries are you guys using? Do you know?
So on this one, we actually have a 200 kilowatt hour battery pack.
Okay.
It's 2 100 kilowatt hour strings.
Yep.
So we think that that's kind of right around the right area to have, kind of on the lighter weight side. It's about maybe a quarter of what you normally see on a traditional BEV tractor.
Yeah.
But then it allows for kind of high loads, like going up a steep grade like Grapevine in California, or coming down from a regen perspective. So we think it's kind of that happy medium for what we have in terms of power coming out of the fuel cells.
Okay, yeah, I'm curious what customers or questions you get as far as like people who are comparing this to a battery electric. I mean, obviously lighter weight from the batteries.
Yeah.
And then the same as far as like this versus a diesel truck. What are the big call-outs you say, other than obviously the emissions difference?
Right, so the emissions difference is huge, right?
Yeah.
Especially now in the state of California, things are changing. We definitely look at the traditional kind of KPIs, key performance indicators of what tractor companies are looking for. So you're looking at total cost of ownership, freight efficiency, how many pounds you're moving per mile per dollar, those types of things. So really we're looking at trying to create not only a green option, being a fuel cell electric, but we're looking at how do we make it the most fuel efficient? How do we make it the most efficient in general?
Yeah.
Can it do the routes and duty cycles that all these other freight operators and so on want to run?
Yeah.
Is it just in the port area? Is it out to Ontario and Inland Empire area? Is it cross country? Those types of things are all kind of considered in terms of when we're doing our design and development.
Makes sense.
Yeah.
And obviously a lot of hydrogen stations are in California.
Sure.
And I guess, do you see much of a plan for like what the cross-country routing would look like? I mean, kind of like with battery electric, we've seen it very gradually growing out, and like, you know, major highways first.
I mean, if you think about it, Class 8 heavy-duty trucks is kind of an interesting situation, right? Because you have known routes that fleet operators run daily.
Yeah.
You have some point A to point A kind of back out and back type of routes that you can really pinpoint and strategically place stations in the future.
Yeah.
So if the demand is there, then the supply will be there. You kind of look and see, okay, where are the key areas? So I think you'll be able to see tomorrow, like the TriGen facility and that kind of situation out there. So trying to work with kind of two main customers, right? We're looking at the truck OEM that's going to buy this kit and integrate it into their trucks and sell it, but really also their customers, the end users, the drivers, the freight operators. What are their needs? So we have to kind of all take that into consideration and try to marry the two.
Awesome. Yeah,
for sure.
Super cool rig. I mean, it's cool to see the other side of it too, and hopefully I'll get to go ride in the actual coated one too.
Definitely enjoy it. It's running out there right now.
Awesome. Okay, leaving that main floor, back to this super cool room, and I've got, what's your name?
I'm Janice.
Janice?
I'm a senior principal engineer with Toyota.
Awesome. And you are going to show me what is probably one of the coolest dynos I've ever seen.
I think it is. So what we have here is a test setup that we use for the development of the Class 8 trucks.
Okay.
So this is the kind of engine, so dual fuel cell stack coming out of the Mirai. This is the unit that's now being produced at our plant in Kentucky. And this test bench allows us to do development that we would do in the vehicle, but in a static setup. That, we can do a lot of changes very quick. No need to drive out, no need to have drivers, anything. We can do it all in the same room.
Nice. So just simulate as much as you want, basically.
That's right. This is a big simulator with the actual hardware. So what we have here, again, same dual fuel cell stack. In our case, we're connected to the radiator. That's the same as in the vehicle. We have a big giant fan
Nice.
that simulates vehicle speed.
Yep.
As the output of the fuel cell, we have electrical power that goes to this junction box, and that connects to the battery, which is this unit here, 200 kilowatt hours, and then out to the motor
Okay.
and the transmission that's back there.
Yeah, so these are all the pieces we just saw on that buck out there, basically.
That's exactly right.
Just split up and separated,
Yep.
but emulating what you would see on an actual truck.
That's right. And then in our setup, we have hydrogen that comes from the station.
Okay.
That's out back.
Yep.
So we never have to run out of hydrogen, basically.
Nice.
And then the exhausts go out this pipe. So when we're running, you see, some kind of white vapor
Yeah.
coming out the front of our building. Coming back further, here we have the motor system. So this is our DC side, goes to the inverter and runs the AC, three-phase AC for the motor. And then we have a 4-speed transmission that in our case, instead of spinning the wheels of a truck, we're spinning this dyno, which is rated to 1.2 megawatts of power.
Nice.
So that converts to about 1,600 horsepower.
Yep.
And it's also rated to about 14,000 Newton meter
Okay.
of torque. So very, very powerful
Yeah.
machine. We kind of oversized it because we expect to have other projects in the future.
Future proofing, yeah.
And so we're not going to build one of these every year.
Yeah.
So that way we have, room to grow.
And this is the motor used on the same truck out there?
Exactly the same one, yeah.
And what can you tell me about the motor itself? I mean, as far as power and...
So the motor is rated to 350 kilowatts
Okay.
of continuous power, and can go up to 410 as peak power,
Yep.
but not continuously whole. And then we paired that to a 4-speed transmission. So you will see when you ride the truck, it has a tremendous torque.
Yeah.
It takes off
Nice.
very quickly. So it's a very good driving experience, actually, for truck drivers. They really like it.
Okay.
So this is one of the good selling points. Very
Yeah.
quiet also compared to diesel.
All right, so we are walking into the sports bar for engineers.
So this is our control area. So these different screens allows us to run the unit, collect data, run the facility, and then the cameras, we can see what's going on inside when we're testing.
Nice. Yeah, this would be a fun job.
It is, yes, very blessed.
All right, my turn for a ride. Oh, this is a fun job.
This is a fun job. You get to drive people around and show them a very, very cool truck.
This is so fun. Sending it, nice. Full ABS, into the turn, hit the apex. That's awesome. It's like your own little racetrack out here.
Yeah.
You set lap times and everything.
Yeah.
All right, I got Matt here, another senior principal engineer, and also has a really cool hat that I need to get at some point. But this is an actual Toyota fuel cell generator, and I just wanted to get, I don't know, tell us the rundown of how this thing works.
Sure. So we made this as a demonstrator for us to really learn more about systems integration, the kind of type of integration that our customer would do, would need to do to put together and package this fuel cell module for an actual stationary application. So in this context, you can see in the center here is our actual fuel cell module. This is a type 1 configuration, which is more like a cube. We also make a fuel cell module that's more kind of a long box. It's a type 2 design. Underneath it are a bank of supercapacitors. These don't have a whole lot of energy. It's really is a power buffer, kind of the same as a Toyota Prius or a Toyota Mirai, and that the battery is there, or the energy storage there, is to kind of absorb kind of peaks, both like an XLD cell or a power up or a power down, depending on the load for the application. And so this allowed us to integrate supercapacitors with the fuel cell with an inverter to be able to provide, you know, a same type of kind of a drop-in replacement for a conventional, you know, gasoline or diesel powered genset.
Okay.
And the format of the box itself is very similar. So what you'll see is you'll see kind of a dividing line here with the radiators that is providing cooling for the fuel cell and for the system. We also have some air-cooled super caps, as well as the rest of the kind of electronics are air-cooled. And then if you kind of walk over here to the side, you can kind of see this is our exhaust area. So it's again very similar to a conventional generator, where we have the large radiator fan pulling air through the radiator that's doing most of the cooling and also providing ventilation, and then exhausting the air upwards. Again, very similar to a conventional system. And then this large tank right here is actually a separator that allows us to take the fuel cell exhaust. There is, you know, water. It's a saturated, you know, vapor stream. So even if you're exhausting that upwards, you're still going to be condensing water. And some customers may want to use that, or they may not want to have condensed water kind of raining out from the top. And so we're able to knock that out and actually have a separate outlet at the bottom. That's what this black hose is for. We have our hydrogen supply system, which kind of regulates the system for the hydrogen into the fuel cell, and that's kind of similar on the other side here. If we walk around, we can see kind of the outlets here. These AC outlets are both 120 volt, 208, 480 volt AC. This is similar to what you would have in a conventional system.
Nice.
And so this kind of really allows us to kind of learn about the different aspects of integration. It also allows us to learn about certification. So to do something like this, we would need to be certified if it would be a product.
Okay.
And there's certain design elements that comes with that, design approaches and sensors that you would need to have incorporated to be able to meet those requirements for certification. So
got it.
That was kind of the learning opportunity for us.
Yeah, so the application is really just anytime you'd normally use a diesel generator, this would kind of slot in place of that. And
correct.
then as far as, you know, hydrogen storage, it's not so much on this exactly, but it's like you can use however much storage you need. So you could have like a pack of, I don't know, 5 tanks, 1 tank.
Correct.
Just depending on your use case.
That's correct. So hydrogen for kind of a commercial application is relatively easy to get. There's a number of suppliers that are out there. So you can get bottles, or you could get actually a trailer.
Nice,
right? So it just really depends on your endurance, your mission profile, as far as how long you want to run at what power level. Kind of judges how much hydrogen you would want to have.
Yep. Awesome. So yeah, great use case out here. I mean, obviously even charging just a couple, a battery electric, but also a plug-in hybrid. Yeah, makes sense. Pretty cool. Pretty neat to see all this lined out, and so much fun. And the supercapacitors, there's like 3 of them in there. Is that?
It's 4 super caps.
4, okay.
One's kind of hidden underneath.
Okay.
Just the way the packaging was.
And how much power do those actually hold?
Well, it's so this is kind of the stack itself can put out 80 kilowatts.
Okay.
We've kind of rated this at about 70 kilowatts net. And so the super caps can provide that kind of power as a pulse power. But it's really about how much energy. We're not disclosing how much actual kilowatt hours it is, but it's basically enough for us as a supercapacitor to be able to allow buffering for transients based on load. And then so basically it's working as a hybrid in the same way a Mirai would work.
Very cool. A hybrid, but a generator. That's awesome. All right, back with Matt out here behind the building. We actually have a hydrogen filling station, which Kyle's already done a video on how to actually fill a Mirai, for example. But I actually wanted to find out, you know, why you have this here. I mean, obviously you're working on hydrogen and stuff, and you actually have direct lines into like the dyno and stuff, which we already saw. But you have this available to like Toyota customers. How does that work?
Yeah, so for Toyota customers, it's on a limited basis. We do it through kind of selected days during the week or kind of limited hours. And we have an attendant that provides that fueling. And that was really done as a way to kind of help out in the local market. We had a couple of stations go offline for kind of a number of months. And so we wanted to provide customers a pathway for them to be able to still get fuel. And so that was about 2 years ago. And so kind of it's stuck, and there was a lot of popularity, and so we've just kept it open since then.
And so right now, we usually fill about 20 customers per day.
Oh, wow.
Depending on kind of how we're able to do that.
Super cool. Yeah, awesome to have this out here. And I mean, how many like filling stations are there in California? Do you know?
Oh, that's a great question. I would point you to the Hydrogen Fuel Cell Partnership website.
Yeah.
There's a page that's on that website. It's called By the Numbers, and that gives you the actual list of stations that are built and operating today, and also a list of all the stations and addresses or areas of stations that are in development.
Yeah.
And so for this station here specifically, the reason that we put this in was actually part of our development.
Okay.
So we wanted to be able to evaluate the fueling protocol and the fueling performance of this station with our prototype vehicles. We also wanted to be able to fill our prototype vehicles without having to take them to a public station. And we also wanted, for the heavy duty side, for our heavy duty trucks, be able to evaluate the fueling performance for that protocol for the trucks. So that was kind of the primary background for that station. And as you mentioned earlier, it also provides a hydrogen supply to our test benches inside the building. And also, we actually walk over here. It actually allows us to evaluate certain components. And so for this dispenser here, this is from Tatsuno. This is a Japanese company. This is one of the first sites outside of Japan that both Tatsuno and Kobelco, which is the maker of the rest of the equipment, made the first system outside of Japan. In this case here, this nozzle is from Nito Kogi. This is not available on the U.S. market yet, but that's something that they're evaluating. So we're evaluating them with them, being able to collect data and the experience of fueling the vehicles here, so we can help this company be able to come to the U.S. market in the future.
Awesome. Yeah, a lot of testing happening. That's a cool looking nozzle too. So clearly their hydrogen truck rips. The Mirai doesn't really rip, I would say, although you can have fun in pretty much any car you drive, technically. But the Mirai is a nice luxury feeling cruiser. Honestly, if you want an incredible deal on a nice driving car and you live remotely near hydrogen, just find a Mirai. There's used Mirais out here for like 12 grand. It's ridiculous. First gen ones are like single digit $1,000, 7 or 8 or 9. But that all aside, it's pretty interesting to see how the hydrogen stuff is actually created, how it's made, how they test it. That 1.2 megawatt dyno is super sick. So now we're gonna see what's happening today, the next day, where they're actually doing all the important, I don't really know what's happening here. It's like a press conference. Obviously here at Out of Spec, we talk mostly about EVs, but I do want to look at more hydrogen stuff, more alternate fuels, biofuels, so many different things you can actually look into and learn about, and you don't just hide yourself into that EV corner. Obviously, I do think that's like the majority use case for a lot of things, and there's a lot of reasons why a lot of companies are focusing on EVs. But I'm curious about Toyota's approach, and I'm curious what you guys think of this multifaceted thing. Anyways, I'm gonna see what experience today has in store, and I'll share what I can with you guys. Over here we have a Kenworth T680 hydrogen truck with 60 kilograms worth of tanks plugged into a Shell heavy-duty filling station. Now, notably, Shell has kind of ditched the light-duty hydrogen game, which is upsetting some people, I think, but seems like they're full send on the heavy-duty situation. So right here, this truck will sit here plugged in. It'll be charging, well, not charging, filling for about 30 minutes if it's really empty to get full hydrogen once again. And over here, not far from the actual truck filling station, is the hydrogen, I guess, junction where they get it. Some of it from TriGen, but they also point out they do get some hydrogen brought in by trucks if they need to. So it just depends how much hydrogen they actually need, what's the demand, they can usually meet it. This right here is a really cool solution as well. No, this is not a hydrogen Tundra, but it's clearly a Tundra TRD Pro kitted out with some interesting stuff. It looks like some aftermarket stuff. I actually don't know enough about Toyota's offerings to know what's aftermarket, but there are like rock lights down there, which is kind of hilarious. That's pretty fun. But the main news is not the cool kit on this Tundra. It's actually what is in the bed itself. And this is a hydrogen power station. Basically a Mirai powertrain is in here, and this thing can be used as a mobile power station. Now, there are no tanks on here, and that's because to carry hydrogen tanks, you have to have special hazmat. Like, there's special stuff required to transport hydrogen. So instead of this being the tanks and everything, it's just the power generator. It has the Mirai fuel cell power situation, kind of like the cube setup we saw in the actual test center from earlier in the video. And this just plugs into existing tanks. So they take tanks out to the desert or wherever a racetrack is. They made a point that with races and things like that, a lot of times the actual carbon footprint is most affected by the actual infrastructure and the tents and like all the diesel generation. And it's, yeah, this is one way to save on that quite a bit. So pretty cool to see this in action here. And they're actually literally are using it. They're powering all the stuff over there off of this thing, which is super cool. So very applicable. I don't remember the actual power output, but it's definitely a better option than a diesel generator and quieter actually. And of course, being hydrogen, its only emissions are water. Nice. It's actually pulling about 9 kilowatts right now. So don't know what the actual max load is, but that's pretty sweet. And you can just adjust, hook it up to whatever amount of hydrogen you actually need. So for this, I don't know how many kilograms of hydrogen they brought. That's the only challenge with hydrogen, is in some cases it's hard to transport, and maybe there's certain safety precautions where just a normal EV battery wouldn't necessarily have those same precautions. So we had a bunch of political talk, more or less, from Toyota leadership, FuelCell Energy leadership, and even the mayor of Long Beach. On one hand, would have put some people to sleep, but also cool to see them out here actually appearing to be very passionate about it. And I don't necessarily doubt that. This is a pretty amazing, immense project. And TriGen, meaning the three things they generate, I guess, tri-generation, which is the electricity, the hydrogen, and even the water. Now, to my understanding, they actually take in 500 kilowatts of power, up to that, but then generate 2.3 megawatts of power. So it still is kind of an excess generation situation, and whatever they don't use, they can actually send back to the grid. They're wired directly into the grid. And the same with hydrogen. Whatever they produce actually fills the vehicles that come into the port, which, by the way, 200,000 vehicles a year come in through this port. I guess 30% of all port input comes through this port in the US. And in fact, on the West Coast alone, it's like 75%. So the Port of Long Beach is a powerhouse and always doing so many things. So this is one of those one small step for man, one giant leap for port renewable kind. Now, for those who are paying attention, there is actually a gray hydrogen and a green hydrogen. Now, green hydrogen is fully renewably made, like made using solar and renewable sources like that. This is not quite made that way, but this is made by what they call renewable biogas. And some of that's done with credits used by renewable situations they have going on in other places. Including how other like renewable biogas is made. So it's kind of a gray area also, but it still is a net positive compared to, I guess, traditional port capabilities like diesel power and whatever else they were using before. Diesel, coal, I'm sure a lot of non-renewable things. This reduces a ton of NOx, a ton of emissions. Their goal, I think, is like 9,000 tons reduced per year, which is crazy. And then the water produced by this, the 1,400 gallons a day, actually goes to the car wash, which is what they use to wash the vehicles as soon as they're brought in off the ship for Toyota. So even the water, which is usually the emissions done by what's, creating hydrogen using air and nitrogen, that water is actually used, again, to wash cars. It's not potable, so you can't drink it, but it is used and reused, which is pretty cool. Also, this is scalable. It's actually built on basically a concrete platform that's not quite a square, it's like kind of a rectangle situation. It's scalable, so you could actually have a ton of these kind of in a grid format, and actually over in Korea they do have that. I guess they said there's one that's like 50 some of these all kind of tied together, making ridiculous amounts of hydrogen and energy. So, and probably a lot of water, I guess. Probably not used for car washes in that sense, but here at a port, it's really cool to see how this is quote unquote leading the way. And I don't mean the quotes as like they're lying. It's just like That's the story, that's the goal. And that's why everyone's here, that's why the mayor's here. It's a really big deal. They kept saying when they were talking on this stage, you're gonna remember this place. You're gonna remember this point in history, which on one hand could be political speak, but also I'm hoping they're right. I mean, this is pretty exceptionally cool. And if one part of the port does this and it turns out to be successful, maybe the whole rest of the port will jump on board and we will see gradually cleaner and cleaner and cleaner air. California's trying to push that agenda because they kind of need to. I mean, sometimes the smog down here is rough. So there you have it. This is a quick kind of dive into hydrogen. More than I was expecting, but that's also good. I've definitely learned a lot. I hope they don't quiz me, but that's partially why I'm making a video, to remember some of the things, some of the facts and figures. But even then, I couldn't really portray everything through this video because there's so much to take in. I honestly could spend like a week doing like a documentary film. Then I'd probably get all the details out to you. But the gist of it is Toyota really is taking this and jumping into this multifaceted approach at renewable energy. Hydrogen, in this case, hydrogen fuel cell, hydrogen combustion, which I haven't seen that stuff here, but I'd love to try a hydrogen combustion vehicle. Of course, hybrids, plug-in hybrids, full battery electric cars. I've been seeing some BZ4Xs coming off the ships over here at the port, and working with companies like Kenworth. But like we saw, they're doing that whole like semi-truck buck thing, so that really any company could come and use that. So maybe if Kenworth starts using it and it proves to be super successful, other trucks will follow suit. And I've seen some electric trucks around here. Like, there's a lot of different solutions. And I think Toyota's multifaceted approach makes me think that there probably is a bit of a multifaceted solution. I think we live in this bubble sometimes of EV is the way. And I think in many regards it is. I would argue that for passenger cars, light duty stuff, I think EV does make more sense. But part of that's just because there's not much hydrogen infrastructure. And even then, like with Shell pulling out of the light duty stuff, it's like people aren't super thrilled to fill their Mirais in some ways. Some probably have a good solution. You know, they live by a filling station. They can go on off-peak hours. They don't drive a ton. It is still a clean car. But I think if you have home charging, EV makes more sense. And just depends on the use case. I mean, even over in Austria, me and Kyle were at Magna. We saw Magna using a battery electric heavy duty truck because it only had small distances to go and it would just get a little bit of a charge every time it stopped to load and unload cars, body in white. So all that to say, a huge multifaceted approach by Toyota. Cool to see the stuff with hydrogen, with the fuel cell energy. A lot of companies doing a lot of good things. And I'm curious what all of you think about all of this. What questions do you have? What things did I miss? I'm sure I missed a lot. I found out about this like this morning, so I'm jumping in blind, but trying to take you on as much of the adventure as I can. So let us know what I missed. What questions do you have? Maybe me and Francie can work on a podcast and like really dig deeper, have some industry experts on this, because I really do think hydrogen is fascinating. Some people are anti-hydrogen, some people are anti-EV. Honestly, I don't really know, and I think that's why I want to talk to more experts and get more opinions, and I do think it probably is a split. EV works for some things, hydrogen works for others. Maybe we'll have hydrogen combustion, and even then we'll have like hybrid hydrogen combustion. I don't really know, but Toyota will probably try it. They'll try everything, it seems, so that's kind of cool, I guess. But yes, before I lose my voice, I will bid you farewell. Thanks for watching another Out of Spec Reviews video. Thanks for joining on this little hydrogen adventure, checking out Toyota's hydrogen technical test center and the port of Long Beach, which I guess the mayor or whoever the MC was like, oh, welcome to sunny California. That was his speech. And yeah, no sun yet, but the sun is coming in theory.